Hello and welcome to Cloud on Board, migrating to Google Cloud. Thank you for tuning in. This is your first step on the learning journey towards becoming an expert Google Cloud professional. My name is Vishal Lingam and I am a Google Cloud trainer. If you have any questions throughout today's event, please feel free to enter them in the text box below the video. We have Google experts on standby who are going to answer your questions live right now. So let's see what we're going to learn today in the agenda. We will be talking about Google Cloud migration strategies, how we are going to actually move to the Google Cloud platform. We'll learn about fundamentals. We'll talk about the access management strategies, resource hierarchy, cost management. We will talk about different kind of virtual machines offering, which are done by the GCP's platform, which are basically compute engines. You will also learn about the networking, which we call as virtual private cloud, which are running on Google's globally distributed network. Once you learn how to migrate virtual machines to the cloud, you will learn how are you going to manage your infrastructure on the GCP and how will you put your governance in place, how you're going to manage your user lifecycle and machine authentication. Finally, you're going to learn about the monitoring and the logging step. And finally, we're going to talk about how are we going to migrate a virtual machine onto the Google Cloud. This session is being brought to you by Fastlane and Google. Now, Fastlane is a globally authorized learning partner for Google and many other large technology providers. Let's get started with an introduction to the Google Cloud platform. All right. The first thing about today is going to be cloud computing. I think that's a very common term. I mean, it is true. There is no cloud, right? It's just someone else's computer. You can talk about actually in this session how the cloud computing characteristics are going to be there. Why there is a need right now to move to the cloud. What are going to be different strategies that we're going to follow for migrating to the cloud in that case. So let's learn what cloud computing really is. With the cloud, what we're actually doing is accessing resources and consuming services which are kind of hosted on someone else's computer. So if you want to be more precise, the cloud is basically a pool of computers. And, if I have to be like really give you a more definitive answer, you can say that cloud computing is basically a model for you can say enabling an on-demand network access to kind of share pool of computing resource or configurable resources like networks or servers or storage, and that can be kind of rapidly provisioned and released with the minimal management effort or service provider interaction. And this model kind of composed of different characteristics that you can have it. You get a broad access to the network across the globe, across cloud computing. And that's what cloud computing is about, like on-demand self-service, network access, resource pooling. Now, what is resource pooling? Resources are actually pooled from a shared pool, actually, which kind of gives the user, you can say, a sense of location independence. So for some of the resources, the location might be restricted also. There are a few more things like think about elasticity. I mean, there could be services that can be elastically provisioned and deprovisioned with capacity being managed by the provider. You also have the resource usage that can be monitored and can be reported on. So, cloud computing is basically an ability where you are, or you can say the customer don't have to know or care about the exact physical location of those resources, where it's basically computing resource on demand or self-service. So that's what cloud computing is for about. I just spoke about elasticity. I believe elasticity is one of the most important thing in cloud computing because as a customer, you want to always expand and you don't want to be really restricted with the kind of infrastructure you have on the premise. So with the elasticity, you can kind of scale up and scale down the way your business or application needs them. And finally, customer pay only what they use or reserve as they go. So if they stop using resources, they simply stop paying for them. Think about a traditional data center where you had to pay for maybe a 3 month contract or a 6 month or 12 month, and regardless whether you use them or not, you were still paying it for them. And that's what cloud computing provides us. It gives us an ability of the on-demand access. That means if I need a specific resource for an hour, I'm just going to pay for an hour instead of out a contract. We have three different sides. We have infrastructure as a service, platform as a service and managed services. Now, when we talk about cloud computing, it's basically infrastructure being offered by someone. That means when you move an application to a Google Cloud platform, you pay as you go for the resources which are you going to use. And they're not going to be any kind of upfront commitment or any obligations that you can use a resource and then you can. Apart from that, what basically happens, if you see, it's infrastructure as a service. That means Google is going to handle many of those lower layers of infrastructure and security because of its scale. Google can really deliver a higher level of security at these layers than most of its customers can afford. I mean, think about if you have a data center of your own, it's very hard to give it a top-notch security standard because it's going to incur a lot of additional cost. Now, when we go to a cloud computing platform and being a GCP user, that's something that you get. You get infrastructure as a service where you are now only required to manage your content, your deployments, and identity. That means you still have to choose a server. It's just that you're not going to manage it anymore. It's more of like running a virtual server where you just choose and define your requirement. That is a compute requirement, and you just trigger the server, and boom, that's it. You're up and running. Then we have platform as a service, which is you can say one more level of manage where now you are basically going to manage your application and securing content. And finally, we have managed services, which is one of the best offering where everything is kind of literally managed by Google, and the only thing you will be managing is your content, your usage, and your application, and the rest everything is going to be managed by the Google on its own. And that's the benefit of the, you can say, migrating to a cloud. And in this session for today, this is something that we are learning at the great capacity. We're trying to learn why there's a need to move to Google Cloud. What are the benefits? And the biggest benefit is what you see on the screen is total cost of ownership. You're not just going to save money, but you're actually going to save time because now you're not managing your resources all together by yourself, but it's someone else managing them for you. And now you're really focused on your business. Let's see what's next now. We'll talk about migration type. Now, how many of you really know about migration types? Put them on a chat. What is migration, anyways? I'll give you 5 seconds. Put that on a chat. What is migration? Now, when you're planning a migration to Google Cloud, what you start? You start kind of by defining that environment. And you see, these are different ways and strategies that we have. Lift and shift, pretty common. You just put your stuff the way they are and put them on the cloud. You kind of rebuild or refactor it, not making a lot of changes, but do it. You do remain on prem. Obviously, like there are a lot of classic apps or some traditional apps, you don't want to move them. You can still remain on prem and use some of the services like VPN on the cloud and connect them from the cloud to on-prem. And you can improve and move, which is like you make some tweaks. Let's say your application was never ready for the cloud, so you will make the necessary tweaks and tricks, and then you will move to the cloud. So those are different cloud migration strategies that we're going to talk about. So let's talk one by one of them. The first is lift and shift. As an on-prem environment, it's basically an environment where you have a complete ownership and responsibility. These infrastructure are going to be typically shared between the customer. There are different environments. You have a private environment and you have a public environment. Now, when you have a public environment, it has some advantage that you don't have to really manage the whole resource all by yourself. You can really focus on the aspect of the stack that is most valuable to you, and then you can move it from there. When we talk about the lift and shift per se, in a lift and shift migration type, what you basically do is you kind of move your workload from a source environment to a target environment. That means from your on-prem data center to the Google Cloud, which becomes your target environment with very few, or you can say no modification, or maybe some kind of refactoring that's required. And then the modification you can apply to the workload to kind of migrate, they're going to be right the least of the changes, or you can say minimum changes that you would need to make in order for those workloads to operate exactly the same way they were working on the on-prem. So you can say a lift shift migration is really ideal for the workloads where you don't have to really change a lot from the source in the target environment, and that makes your things faster. So when your speed is required, you do a lift and shift. When you know that the risk is going to be minimal, you do a lift and shift. When you know that your application can run the same way on the cloud without much modification, you do a lift and shift. And finally, as I said, if there's very little need for a change, you do a lift and shift, and that's the fastest way to kind of migrate to the cloud. So once we have lift and shift, what next? So we have improve and move. Now, one of the migration strategies is improve and move migration, where you basically you can say modernize your application or workload to kind of suit the environment you're trying to move. Let's say which is cloud. So when you have you can say a improve and move type of migration, you modify the workloads to kind of take the advantage of all those cloud capabilities which they were not built before, and then you kind of enable them to work with this new environment, which is something where you have to invest some time and effort to see what cloud platform you're moving. And if you're moving to the Google Cloud, how are you going to make those necessary changes? How much time and effort is required? And then you kind of plan that movement across that. Wonderful, understood. What next would be then? Rebuild. Now, what could be rebuilt? Think about it. I'll give you 10 seconds because we just understood the lift and shift and you understood the improve and move. Think about rebuild. Just type on the chat, on the comment. What do you think rebuild would be? Now, a rebuild migration is where you kind of, you can say, decommission an existing application and then you completely redesign and rewrite at is like a more of like a cloud native application. So let's say you have an application, for example, you don't want to maintain it. You know that it's very costly for you to migrate, and you know that it's not even supported on GCP. So you have a problem, right? Number one, you know it's costly, so you can kind of rip it, replace the migration, and rebuild on the platform. So because both, if you think about rebuild and move and improve strategy, they involve some kind of code refactoring. So obviously they're not going to be the scope within this session, but you should understand how they work. And finally, is the on-prem is that let's say there's something very specific workload that you want to keep on-prem. There's always an option. You can just put things on the on-prem instead of moving to the cloud. Think about like a mainframe machine, or you have some kind of incompatible licensing agreement that your cloud is not going to provide you, or you have some kind of compliance constraint that you have to keep it like in the local data center. You can have that. Let's say if you have some kind of unsupported operating system, that's something which is there. So there are some different options that you can really have it when you're trying to move there. The migration process, this is one of the important slides that you should really focus on, because that's how the entire course is going to be structured on, or I would say that that's how the entire streaming is going to be all about, how you are going to migrate. The first step is to assess, which helps you kind of understand what your source environment is. Basically, you realize your servers and storage, different application type, the operating systems. If there are licenses required for that, you kind of basically visualize everything. You understand how that's going to work. And the different automation tools which are available in the market, like the starter zone that I told you about in the morning, in the agenda at the start, that's one of the ways that you can do it. Where you can really use those application, or you can say they're more of like an automation solution which you can use to build your environment. They can give you a lot of migration recommendation, and they can predict the cost in the cloud. Then we come to the prepare phase, and what happened in the prepare phase, once you understood what is going to cost you and what you need to build on the cloud, you basically have the foundational knowledge in order how you architect and implement an infrastructure environment on the Google Cloud Platform. And finally, you have the migration phase. Now, what happens in the migration phase is that you will configure the process of how you are going to migrate. That's what kind of resources you would use. And in the modules later, you will talk about the networking and how your compute is hosted, the GCP infrastructure, how do you migrate a VM, etc. That's where you want to learn in this phase that, okay, now I have assessed my environment, I have prepared myself, let's migrate. So you will actually do a proper migration of moving a resource from an on-prem to a Google Cloud. And finally, one of the most important things for running any business application is optimization. Now, once you do this, we'll talk about optimization, like the governance topic, like well, identity resort, like who is going to access what. You don't want to have everyone having access to everything. So we'll talk about the resource hierarchy. We'll talk about network sharing. We'll talk about identity policies and rules, who's going to access what at what time, what product, what resource. There's so many things you want to be restricting to to different people in your organization, right? And once those VMs are migrated, you've got to optimize them. You've got to understand how they're going to be having the elasticity enabled for them, how you're going to enable automation, or how will you leverage the Google Cloud global infrastructure. And we'll understand about a bit about monitoring and logging using one of the Stack, because you want to know at all point of time that if you're running resources, how am I going to monitor them? All right. So this is going to be entire process. I mean, this slide, if you look at it, assess, prepare, migrate, and optimize. That's what you are going to focus, not today, but throughout your entire career once you even do this, because migration is one of the most important thing that any cloud you can say individual who is interested to kind of move it there, learn it there, they will actually follow a process. So this kind of brings us to the end of module one, and we have some questions, and let's see how they're going to be really worked upon. Welcome to the module two, which is assessing the source environment. And as a reminder, if you have any questions, please enter them in the text box below the video. We have all experts on the standby who are going to answer your questions live. In this module, we will learn about how we are going to discover and analyze your source environment with an assessment automation tool. This tool will assist you in identifying the virtual machines to migrate to the cloud. They will allow you to understand how will you predict the workload, the total cost of ownership that we spoke in the previous slides, and what it would take to run a virtual machine on the cloud. And also, it will allow you to understand how do you optimize your cloud build by, you can say, providing the virtual machine recommendations. In this module, we're going to talk about the assess phase. We'll talk about cloud physics, which is an automation tool. We'll talk about how to choose VMs to migrate with a final demo. When we talk about the SS phase, it's the first phase in your migration to Google Cloud where you determine the requirements and dependencies to migrate your apps to the Google Cloud. You got to be having deep knowledge about the applications you want to migrate, the requirement, their dependencies, and about your current environment. You need to understand your starting point in order to, you can say, successfully migrate and plan and execute you can say full-fledged Google Cloud migration. There are a lot of tools in the market which can help list your you can say virtual machine inventory, because you're not going to do the manual job and think about, okay, fine, on-prem I have, let's say, maybe 100 VMs. On the cloud, how many will I have? I mean, you're not going to sit and do the manual job. That's going to be tedious and time consuming. It's better to use some kind of automation tool. And Google has partners with like Cloud Physics, Stratazone, and Cloud Maze to provide you with a free automated discovery tools to help you assess your environment. If you see, now we're going to talk about Cloud Physics, which is a great automation tool. It's one of the third party solutions that you can leverage to automatically discover your environment. Cloud Physics is a solution that helps you to understand um, your total cost of ownership while also allowing you to analyze the actual usage of the resource over time. And these capabilities, um, enable you to make a, you can say, a side by side comparison between the total cost that is running right now on the on-prem environment versus when you go to the cloud, and it will really help you to choose which virtual machines are really relevant to migrate and which ones are not. Cloud Physics provides you, I would say, an easy to deploy a non-intrusive virtual software appliance. It's kind of installed within your on-prem environment, and it just needs, you can say, the read-only access to your VMware vCenter. So Cloud Physics, it does not deploy any kind of agents if you're worried about that to your ES6i host or some kind of guest virtual machines. Any kind of communication that happens with the help of Cloud Physics, it's achieved through, you can say, your existing management interfaces, and it has no performance impact on your virtual machine. And if you're using AWS, so what Cloud Physics does, it uses the same kind of approach by leveraging the AWS APIs instead of kind of getting your data directly from the EC2 virtual machine instance. What Cloud Physics does, as we have spoken about, it collects data from your on-prem environment using a virtual appliance, which we actually call as a Cloud Physics Observer. Now, remember, if you are planning a migration from an on-premise VMware environment, you need to install this virtual appliance. The Cloud Physics Observer is a minimum resource appliance which is designed to you can to collect the data from your VMware vCenter, and then it actually uses the read-only APIs. It processes the data, and then the data, when it gets processed, it kind of shares that data to the Cloud Physics web portal, and then the observer that you've deployed on the your VMwares, it kind of collects your on-prem VMware performance and configuration data. You can say, in order to provide you a very holistic picture of your environment, and then you can kind of think about it, how that's really gonna work. Now, once we have understood the cloud physics, after installing the cloud physics, obviously what is next there? You will have an understanding. Okay, all right, these are my virtual machines. I want to migrate them. There are different strategies you can choose to define which VMs are good to migrate, which VMs are not. I mean, for example, let's say there are different kind of applications that may be running inside that virtual machine. Think about those customer-facing apps like the website, or some kind of back office or developer tools. So when you talk about those migration, there are three categories that you will always or you must remember while you're migrating that. The first one is easy to migrate. These are the easiest one, actually. I mean, these are the apps which have the lowest dependencies. So when you're using an easy to migrate, think about like a website, right? You just copy the data and then move that to on the cloud. Just a very simple example, which has very less dependencies, and they're like newer, which are written internally. So you have, I would say, no licensing consideration, and then you have these apps which are pretty tolerant to scaling. So you have, the first thing to understand, is my app easy to migrate? That's one thing to remember. The second thing, the apps which are kind of harder to migrate. I mean, when I said an example, think about an application now which has a lot of dependencies. So, in order for you to migrate it to the cloud, you have to really figure out, number one, the virtual machines it's running. Number one, the requirements that you would need on the cloud, what kind of dependencies it's already having, how will you achieve those dependencies? If the app is, let's say, less tolerant to scaling or have some kind of complex requirement, you've got to figure that out. I mean, if it's really a right choice. And finally, you have something with like the apps that won't be moved at all. I mean, there are apps that might not be, I would say, a good candidate to migrate or run on, specialize older hardware, or you have some kind of business or a regulatory requirement which is making them compliant to stay on the on-prem environment, which is your data center, or have some kind of complex licensing requirement which doesn't allow them to kind of move out of the data center to the cloud. So one of the ways, how you will sort the VMs for migration. So let's say you have defined all those VMs and say, okay, VMA will be good to migrate, VMA is difficult, VMA3 is not. How do you define them? Is that where you kind of put the tag, or you can tag your VM by the level of migration difficulty, or some kind of application that's running on that environment. So it's very important to do that. Cloud Physics has something called as cards. Now, what are cards? They're basically nothing but the collection of data. So think about like there's a host analysis card. So what this card will do, it will provide you all the necessary information with the hardware related reports, or maybe some kind of a guest OS card, which is going to analyze which system within your infrastructure is running what kind of operating system and version. So you get cards which specifically defines the collection of data that's going to happen. So once you explore these cards, the main goal that you would always have is to identify and tag your virtual machines which are suitable for migration, maybe harder to migrate, or let's say finally they're like you can say they should remain on-prem, right? So if you think about a host analysis card, I mean, this is the middle one. on the slide, the center one. This card, it's just a small insight. It gives you an overview of the current hardware that's running in your VMware recent environment, all the versions which are deployed into the ESXi hardware. So this card is really useful if you're trying to identify and tag the virtual machines which are running on the ESXi hypervisor versions, and then they're kind of about to enter, or let's say they have already reached end of support. So this card gives you all those relevant information. And when you are identifying these hypervisor, they really helps you to, you can say, mitigate all those stability and security risks. So it's very important to know about these cards, and you should understand why these cards are there. So if you use cloud physics, you will know what's there. Apart from host analysis, there is also something called as a guest OS analysis card. Now, obviously, when you're running VM, there has to be an operating system, right? So each workload which is running a data center needs to have an operating system. So, gaining the insight into all those operating system families and the different versions that they're running in your data center, they can make you aware about the risk and the opportunities within your organizing workload. So, we know that each environment is going to be different, correct? And this guest OS analysis card, it can provide you some kind of a filtering mechanism that will help you to do some kind of bulk tagging or untag, or all those VMs that are, let's say, running a specific version of operating system. Let's say you have a operating system licensing agreement for a specific operating system which cannot migrate to the cloud because of those terms and conditions or certain criteria. And how would you know that? Let's say if you're planning a migration, how would you know that? So the guest OS analysis card, it can help you to kind of easily tag the virtual machines which are running these operating systems, and then you will put them, okay, these machines are not suitable for migration because I cannot really move my licensing agreement to the cloud. And then if I try doing that, I have to pay an extra money, which I already paid for this one. So you kind of tag them, okay, these machines are not suitable for migration. That's one of the example that you can use with this guest OS analysis card. There's one more card I want to talk about is the on-prem IT simulator card. Until now, we've spoken about the network side and the OS side, but knowing the estimated cost per workload on the on-prem workload is really critical in order for you to make that decision, or a business justification whether you want to move to the cloud or not, which is actually the purpose of this you can say on-prem IT cloud simulator card. And I would say if you're using cloud physics, this is one of the important card that you will always keep a track of. There are multiple variables, as we understand, that can affect your cost per workload. It will give you deep insights in your hardware, in your software, your management, all those things, which are basically the key to, I would say, establish an accurate, or I wouldn't say accurate, let's say a very near to accurate total cost of ownership. So the on-prem IT cloud simulator card will do just this. You can easily build a proper business justification whether you want to move to cloud or not, and if you are, what are the things that would be required, the costs, etc., and on what parameters those costs are involved. Because when you're running your infrastructure on prem, there is a you can say we're always more easy towards allocating resource. And I'll tell you about a scenario. For example, let's say if you're using on-prem resource and you have to allocate, let's say, CPU, and there's a request to the admin. So the admin will say, okay, fine. If you need 5 vCPU, fine, I'll go ahead and give it to you. There will not be a question why you would need that. It's a tendency, but we're always more generous because we have a lot of resource. We've paid for it. We know that if we allow 5 vCPU or 10 vCPU, it's not going to make a difference because I've already bought that server with that capacity, right? So most of the investment is kind of paid upfront when you buy that underlying hardware, and therefore it is not uncommon to over provision. And these VMs are the result of them. Now, I would say, in addition to, I would say, potential to create the connection between the VMs when your fleet is going to grow, you have that over allocation of the resource. If you do that on the cloud, it's going to really, really make your cloud bill boom up because you are allocating something as a resource and then you're using it. So you are going to get the bill for what you have resource allocated for on the cloud. So when you're doing a lift and shift to the cloud, you, as you remember, we say we pay as you go and we pay for what we use, not what we allocate. So it's like if I'm allocating, let's say, 10 vCPU And if I'm allocating, let's say, 10 gig of RAM, and I'm going to only use, let's say, 5 gig max, I'm still going to pay for 10 gig because that's what I've allocated. So on a cloud environment, over allocating is never a right choice, and that's what this card really tells you. When you kind of lift and shift, you pay for what you allocate. Therefore, a proper right sizing of the VM resources based on the actual use is very, very critical, and that's why this card is really, really important. Okay. Then one of the favorite cards is the GCP Cloud Simulator card, which actually matches your virtual machine to GCP compute into a virtual machine instance type, and then it's going to predict the total cost that would be required. So let's say if I need a machine with the two vCPUs and 3.5 gig RAM, then this card will tell me, okay, this is the machine type that you should use on the Google Cloud to kind of match your compute requirements. So this similar card can include all those tagged VMs or all those VMs that are compatible with the GCP. It can exclude also the VMs which cannot be migrated based on the tags that you have given. So right sizing is, you can say, leveraging the analytics based recommendation for how are you going to map the on-prem instances to the cloud instance type. Because let's say if I know about my on-prem instance, right, and I don't know what kind of instance or compute I will really get on the cloud, isn't that going to be really hard? So now you should think in this direction that, okay, if I'm planning for a migration and I know my on-prem environment very well, but I really don't know the environment on the cloud, what machine type I'm going to use, who's going to recommend me, that's where the GCP Cloud Similar Card is going to help you if you're using the cloud physics. With this part, you can actually in cloud physics, you can configure the simulation to kind of estimate how much the migrated VMs will cost based on the same configuration as you have on-prem. So let's say if I'm on-prem, I have a 10 vCPU and a 10 gig RAM machine. I'm going to put that thing on and I will get to know, right, I'm going to get paid, let's say, I'm going to get charged, for example, maybe $100, etc. So there are different performance metric that you will then utilize, and that's what Cloudflare does assess for you. Like, what is the peak CPU usage for you? Let's say, for instance, there's a software update, okay, and that software update has caused the virtual CPU on a specific virtual machine to have a temporary spike. Now, if you have a scenario like this, that CPU spike is happening not due to that generic, you can say, a load, but due to that specific event, and that's not the reason. So it is for this reason, the peak usage metric, I would say, they're often considered less desirable to determine the actual CPU utilization you need. And but despite that, the vCPU peak metrics, it will really ensure you that your virtual machine has the necessary resources during those time of the use. And the better solution to this scenario would be is to properly right size your, you can say, future cloud environment, where you kind of achieve that 99 and 95th percentile performance metrics. If you see this in the slide, we have a VM name and the CPU peak usage and the 99 percentile, 95th percentile. So it's really important to understand. And when we talk about a 99 percentile, it kind of refers to the maximum CPU utilization for 99% of a time a system is running. And then the 95th percentile works the same way, but it kind of determines the maximum CPU utilization rate for the 95% of the time a system is running. So there's two things that you should really know when you're actually doing the right sizing. And I believe right sizing is something really, really important when we are talking about that. Once we do right size, what else we can do? We can have a lot of recommendations, right? I mean, GCP should give me a recommendation that is my CPU, the one or the machine or the compute instance that I have chosen, is it the right fit? If not, then what can we do? That's where we have something called as recommendations. In the Google Cloud, you have something called as recommendation, which really helps you to understand the whole process of this. Compute engine machine type recommendation basically allows you to optimize the resource utilization of your VM. What it does, that your compute engine on the Google Cloud, it kind of monitors the CPU and the memory which is utilized during the running of that VM, and then makes a recommendation using the last 8 days of data. So what it does, the compute engine makes recommendation. Let's say If your instance is having a low CPU utilization for last 8 days, so the compute engine is going to recommend you a machine type which has less virtual CPU, so that it knows that, okay, if I have 8 vCPU but I'm only leveraging, let's say, a 4 for a long period of time, then I would say the compute engine will recommend me to use something which is 4 vCPU because I am not using it to the full capacity. Or let's say if your CPU has a high CPU utilization, then the engine will recommend you a machine type with more virtual CPU. Or let's say if your instance hasn't used the memory to its full capacity, then compute engine will recommend a machine type with less memory. So, and same thing goes with, like, if you're using it for, let's say, more memory, then it's going to give you a more memory recommendation, a machine which will have more memory. So your compute engine may make recommendations to use, you would say, either a standard or a custom machine type, and then you can really use that. So right side recommendation is a very important thing, because you really get to choose the right type of machine, so that you pay for what you use, not for something that you're not using. And that's one of the things that Google Cloud provides you. It's a great feature you must leverage when you're actually planning a migration. You got to monitor your machines and then see if I or let's say when I migrated the environment, is it the right way or not. What we have learned till now is a process of assessing. If you remember the migration process, this is what we've learned. We've learned how to discover and analyze your source environment with an assessment automation tool, which basically assists you in identifying the virtual machines to migrate to the cloud or not, predict the total cost of ownership of running those VMs in the cloud, because that's the most important thing. You don't want to get burdened with a bill, and go crazy. I mean, you got to learn how to optimize your cloud by providing the recommendations based on the right sizing. So we've learned all those things, and this is one of the most important thing that we would have in this case for us. That brings us to the end of the session.